In previous, we have discussed about velocity, distance, displacement, acceleration and retardation. So in velocity, we have discussed that the displacement in a body or in an object with respect to time is the velocity, and acceleration, when it changes in velocity in per unit time, is the acceleration, and when this goes to negative or in the opposite direction, so that we call it as retardation. Now in this session we will see position time graph. So in position time graph, first we will see when the object is at rest. So when an object is at rest, so this is our y-axis and this is our x-axis. In x-axis we have considered time, that is t, and in y-axis we have taken distance, that is x. So with respect, when the object is at rest, then we get the graph like this. When an object is at rest and with change to time or change in the time, the object is seen to be at rest. There is no movement in the object, then this graph will be generated. Now in second we have discussed about uniform motion. So when an object is at uniform motion, uniform means the distance traveled by an object in an equal interval of time, that is the uniform motion. So when an object is travel equal distance in equal time of interval, then we get a, that is distance x. So with respect to distance and time, we get the straight or straight line. As the time is changes, the distance or the position of the object is also changes. Now in second graph we can see that, this is x-axis, this is y-axis. Now if we get graph like this, so in this we can say that the object is returning. In this we can say that the object is reaching at its initial position, and in this the object is returning to its final position. So with this we can make one graph with time, and so if the object is reaches at its initial position, then it will comes back to its final position. This is the uniform motion for position time graph. Okay? When an object is reaches at initial position and at final position. This is x-axis and this is y-axis. Now when object is at non-uniform motion, when an object is at non-uniform motion, we will get two graphs. Either the velocity is variable, then it will be acceleration or retardation. So when the velocity is variable, we will get two types of graph. Either there will be acceleration or there will be retardation. So for acceleration we will get like this of graph, and for retardation we will get like this type of graph. This will show the acceleration and that will show the retardation. This is acceleration and this is retardation. So acceleration and retardation, these are the position time graphs. Now with position and time, we get the velocity. So calculation of velocity with the position time graph. So this is time t and this is distance x. When we get a straight line, so the displacement, we have to find the velocity so that we to calculate the distance of two places, that is from x1 to x2, how the object is displaced its position and how the time is changes. So we know that in this, if we have like this, then the theta will generate. Now tan theta is equals to, we can give name to these P, Q, R, that is perpendicular upon base, that is PR upon QR. So this QR will be equals to T1 and T2, and this P2R will be equals to P2Q. Now tan theta will be x2 minus x1 and QR will be T2 minus T1. 2 is the slope or a straight line. Now we know that velocity is the change in position upon change in time, that is x2 minus x1 upon T2 minus T1. This is the calculation of velocity from the position time graph. If the distance is very low, then or very small, then we can say that del x upon del t. Del x upon del t. In retardation or acceleration, we get a slope. So for slope of an object, how we will calculate? So we will draw a tangent. With this tangent, we will draw some points. In this is our time t and this is our x0. So for every point we can take anywhere. So here we are taking t1 and here we are taking t2. x1, x2. So the displacement between 2 points, that is here also it will generate a tan theta. Then tan theta will be equals to, this is A, this is P, this is Q and this is R. Now we can say perpendicular upon base, that is QR upon PR, that is equals to x2 minus x1 upon t2 minus t1, and velocity is also equals to change in position upon change in time, that is x2 minus x1 upon t2 minus t1. So like this we can obtain a velocity from the position time graph in a uniform and non-uniform motion. Velocity time graph. Now, when the position of an object is changes with respect to time or in a uniform motion. Uniform means the time is changing with respect to distance. So this is our uniform motion, or we can say that the velocity is positive. So positive velocity. Now, if the velocity is negative, then like this type of graph is generated, that is below to the x-axis, that is negative velocity. Now, if the object is stationary or the velocity is stationary, that is not changing with the time, then like this graph will generate, that is zero velocity or zero velocity with respect to velocity time graph. V0 will be here. Here also time will be this side and velocity we get here. So these are the three types of velocity from the velocity time graph, that is positive velocity, negative velocity and zero velocity.